It's not
chilly.
So.
But I saw my parking spot this morning, so I'm happy. On the happy side today.
You no one was in it?
No.
Was anybody in yours this morning?
No. Oh my gosh, you should have saw me park yesterday. So I couldn't see like I said, couldn't see anything. So I just parked, estimated. So I get out there yesterday after school, and the parking spot line, like the pull up, is right here. My car is right here in between two parking spaces. I thought it was hysterical.
Nice.
It's literally right next to it.
My friend was between like 17, 16, and like 17. So I was like, I was there.
My friend parked how like the lines go this way?
Yeah.
He parked this way. I don't know.
This off. I'm just kind of getting ready here. We got plenty of time to do everything today. We're good to go.
Can I ask you a question?
You sure can.
Who teaches business math?
I think it's Mr. Petrello.
Just like
He's over in East Unit by Mr. Gallagher. The thing is that next year, every year can change what we teach, and usually, and next year there's going to be kind of a rearrangement of what we're doing. So there could be a shake-up of that. There might be somebody different or somebody new, including him. But I think right now he's the only one that teaches.
You should teach business math.
But I
should. You should.
I could.
Or Mr. Sullivan.
The one thing I have not taught at this school is calculus. I taught everything else below it.
Was it Mitter teach calc?
Yep, and Wyndham. All right, let me take attendance in here real fast. If you're here, don't say anything. Just kidding. You don't need to say anything. I can just look at it. I think Rachel and Rachel might be the only one missing today.
Ollie's not here.
He won't be. He had to change his schedule.
Oh, he did?
Yeah. It's just hey, Yusuf! Yo, Yusuf! No, I don't want that. There we go. All right. So we got ciao. Yep, everybody's here. Perfect. Other than Rachel Mitter, who's off swimming, or she's probably not swimming. She's up, ready to swim and represent the Firebirds. Any exciting news to share today? Anybody? Anything fun going on for the weekend? Anybody got big plans? You're gonna do perms.
Huh?
You're gonna do perms just for
I
fun.
already did it. No. I was training to serve at work last night, and I almost dropped a shake over drinks on the table. Thought that was
That's not good.
exciting.
That's not how you get good tips.
Yeah, I know, but
There should be a perfume called Perfume.
that would be amazing if it smelled better than what a perm.
No, it just smelled like perm.
Oh
Called
yeah,
Perfume.
no, that would be like canceled. I was at the whole con.
That would be a joke. You give somebody you don't really care about. Oh, I got you a bottle of perfume.
My mom would love it. She likes the smell.
No, nobody likes the smell of
she
perm.
likes the smell of perm. I know.
All right. I'll put this back on now. I'm done eating my apple.
I don't think I'm doing anything, but at least that now I know from just yesterday that we're not doing logs, something library.
Yeah, today we're going to make sure that you are okay with all those questions from yesterday that we did not go over, which I'm sure you are. And then I want to see if there's any general questions you have. Okay? So, yesterday, when Rachel wouldn't show me her worksheet, I was kind of mad about that. I took it personally. She wouldn't show her worksheet. God, her dad came in and just... Here we go.
She's not here, so
I know she's grounded. She's not. So this is the actual, when I did it. Now, I know we had already gone over most of these. I think there's only a couple we hadn't talked about. So, are there certain ones, which ones do you have to still look at?
Number 5.
5. Yeah, there's 5 on the bottom. Let me zoom in a little bit more on that.
Are you gonna go over these?
That's what I will, anything that you want to, yes.
All right.
But I want you to kind of look at it. And the idea is, can you figure out what's going on or not? And if not, I will gladly do any of these problems you want. Gladly. Let me check this real fast. Shabba-ba-ba-ba-ba-bum. Back. Shaw. Okay. La, 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 la. So you actually want like on number 5, you had like multiple parts. Like this was the first thing you had to do. Then you had to do this next. And then you had this piece and this piece. So there was 3 pieces to this problem. And this one really just comes from here. So is there anybody that like needs to talk about the first part of number 5? Are we okay in the first part of number 5 at least? Are we? Yes?
I just kind of was confused of which equation to use.
Half-life. Where's it at? You still have it?
Hmm?
You didn't like use it for like putting your
Well,
gum in or something?
I wasn't sure if it was that one or the continuous growth decay of half.
Okay, it's both. But when the first problem here, when it gives you a half-life in years like this, you use the half-life model. Down here, when it says to change to continuous, then you have to go to the continuous model. So you're using both in this problem.
Can I have a gold and a purple sheet? Like I was doing it on a separate piece of paper, but it was starting to get kind of confusing.
Hi, Savannah. Would you like one too?
Yes, please.
Did I already give you guys the golden one or not?
I have the golden one.
Oh, okay.
I don't have the purple one.
Oh, okay. These are Bellbrook colors, aren't they? Ooh. Ooh, Bellbrook. Ooh. You're welcome. Oh, slow. All right. So we're okay on number 1. What about number 2? The second part of it.
I didn't get that far.
You didn't get that far, or you don't get it that part?
No, I didn't get that far.
Oh, okay. I mean, I guess the question is, what would you like me? Yesterday I asked you guys to write on the top of your sheets like how you felt, like 1 to 10 on there. Didn't I do that yesterday with you guys?
Yes.
Okay. I need to know now if you're not at a 10. You know, you're not at a 10 or a 9. If you feel like you're below that somehow, what is it that I can help you understand better? Where is it that you need to focus to get a higher number on that sheet? So I need to have an idea of where to focus to help you. That's what I need. So does anybody want to willing to go out there and say, this is where I struggle? Hamza.
Can you walk us through changing it from the decay model to the continuous model?
So you're saying from a half-life
Yeah.
to a, oh yeah. How many of you feel like that's a struggle somewhat? Of course. Okay, great. Let's do that. Let's do that. Oh, wrong one. Ciao. Here we go. Whoa, wait a minute. What was that? It's not what I want. It's time for a new computer. I need a new computer. Okay. Boomba. Look at this. I already planned for this question. Isn't that crazy? I've already planned for that question. There it is. See it?
Oh,
Way ahead of you. I read your minds. You don't even realize how much I read your minds. Up there at the top, it's a half-life model off the gold sheet. That is the continuous model off your gold sheet. Now, for both of these to be equal to each other, they have to have parts of them be the same. So, I mean, when you look at this, what do I know? Well, this y and this y are going to be the same values. This initial value and this initial value have to be the same, right? What other variables do they share? What? But they share t. The only other one they share is t. So t has to be the same in both of them as well, right? Now, it's kind of hard the way this is written to grasp what's going on here. So I need to now use what I keep telling you is the most important law of exponent you need to know, which is what? Power of power. Now, here's what everyone has to remember. Okay, if I gave you this, if I gave you something like this, that's equivalent to what? 5 to the third raised to the x. I can factor those and write it like this if I want, correct? It's just the opposite. Okay, so knowing this, I'm going to come back up here. And I'm going to concentrate on just these blue pieces. And I'm going to rewrite those and factor the exponents. So this is going to be 1/2 raised to the, now watch very carefully what I'm going to do. I'm going to put the t as the outside exponent. So if I remultiplied this, I would just get t over HL, right? I want to do the exact same thing here. I want to do this one so that the t is on the outside. So that means it would be e to the r raised to the t. Does everybody understand that? Mm-hmm. So now, as I was saying before, these t's are the same. So these are the same. Now I told you these have to work the same way. These equations must be the same. They look different, but they're going to give you the same answers. So guess what? That means that this has to be equal to that. Those things are both my value of what? B. Those are my bases. Watch what's going to go on here. E to the r is equal to 1/2 of 1 over the half-life. Are you ready? Help me write this as a logarithm. It's exponential right now. Let's write this as a logarithm using natural logs. What would this be?
A natural log of 1/2.
Uh-huh. Raised to the
1 over
1/HL is equal to R. Now remember, we're trying to find the continuous growth rate. That's what I have to know. I don't like that, the way it's written. Guess what I'm going to use? The power property for logarithms. Where's that go? Out in front. So guess what R equals now? 1 over the half-life times the natural log of 1/2. And guess what that's equal to? The natural log of 1/2 divided by the half-life. That is always true if you're going from a half-life model to a continuous model. That's how you find R every single time. It's the natural log of 1/2 divided by the half-life. There it is. So that's, if we just did it algebraically, we see now that this is what you could just do every time. And Mr. Minner was in here yesterday saying that. He was saying, just take this, that's what he's saying. It's the natural log of 1/2, and you always divide it by what the half-life of the item is. That's how you find the continuous decay rate. And if you know that, then you can write your equation. Because it's e to this raised to the t. Boom. So let's just try it. Here we go. Let's say by chance, I give you the following. I tell you here's the half-life model for peanut M&Ms at my house, how quickly they decay. Because we go through them at my house really fast. Okay, so I could buy a 100-pound bag, and the half-life of that is 5 days. Okay? 5 days. Change it to continuous. Change it to a continuous. Okay? And this 5 days, months, I just have to know that in my head. In 5 days, that's what's going to happen. The half-life is 5 days. So that means in 5 days, they'd be down to 50 pounds of M&Ms left. So now I want to change it to a continuous, which is a so how am I going to find the continuous rate of decay? What's going to go on top? R equals the natural log of, it's always going to be 1/2 on those problems, divided by the half-life, which is 5 days. I just need to know it's days, not years, not months, not seconds, it's days, right? Boom. All right. So now this would be what then? Y equals 100 times E to the, this thing if I want, times T. Now, if I actually wanted you to find R as a percent, you would just do what? Do this in your calculator, correct? Yeah, you could just do it in the calculator. Let's go ahead and see what that gives me. Shaka-doo. Okay. So we got the natural log of 0.5. Boom, bam, slam, wham. So I get negative 0.13863 roughly. You guys agree with that? Yes, no, maybe, hopefully. So now I could write it as y equals 100 times e to the negative 0.13863 t. Okay, so here's the deal. If I asked you how many pounds of M&Ms left after 28 days, these should both give me basically the same answer. Will it be a little different? Yes. Why? Because I did what? I rounded. So they'll be a little different. So let's just say, hey, 28 days. And bump, bump, wow, those are really close. Who can tell me what this gives me and round it to the nearest thousandths? Nearest thousandths.
2.062.
Beautiful. 2.062 pounds would be left. If I come down here and I round it to the nearest thousandth,
2.06.
There you go. Okay. That's that whole continuous idea right there. That's it. Anybody else got a question? Something they want to, I mean, that was what you were talking about. Half-life to continuous. So half-life to continuous, find the continuous rate of decay, natural log of 1/2 divided by the half-life, boom, bam, slam, got her. Got her. What else? Anything else you want to talk about? Or is there a certain type of problem you'd like to say, I'd like to try one like this, Mr. Snyder, to make sure I do understand it? It can be anything, guys. I can create problems like, boop, like a Newton's law of cooling. How are we on that? How are we on Newton's law of cooling? And? Okay, so we're we better do one. Here we go. Oh, I know exactly what this problem is. Here we go. I'm going to type this one so it looks nice and neat.
He's going to start talking about coffee.
No, it's not about coffee at all.
I thought it would be.
Okay, I need a font that's not like monster sized. Oh, I like this one right here. 36. Okay, here we go. Do you know what that means?
Like cooking pots?
What's it mean if he throws pots? Anybody know what that means?
The little air gun thing that he has.
No. It means he's a potter. It means like when you throw pots, you actually create pots. Like on a potter's wheel, then you that's called throwing. Throwing is the act of making a pot, okay? So he throws pots, okay? Great. Okay, here we go. He just pulled up. Okay. Mr. Snyder's birthday present out of the kiln. Its temperature is 575 degrees. Boop. Perfect. He places it, he places it in his 75-degree classroom and sees it is 535 degrees in 10 minutes. How long before he can hand it to Mr. Snyder if the temperature needs to be a minimum of 110 degrees to hold without gloves. Pikachu! Woo! There you go. Love it. And he has a kiln in his bathroom. You didn't know that?
Bathroom?
Huh?
See bathroom?
That back, he has that room behind his desk and all that?
I think it's the
There's a
bathroom.
kiln back there. Not really, I'm making all of this up, but that's okay. I make a lot of story problems up.
I was about to say.
I make a bunch of stuff up like this. That's my job, to be able to create problems on the fly if I need to. La, la. Da, da. Shiva. Yusef, you better be trying this.
He's not.
He's a goon. Yusef, Goonsef, same thing.
Whose problem? Why did you do that?
What's that?
Hold on.
Huh?
I'm thinking.
Remember, these are almost always going to be two-steppers.
Oh,
I'm just... Yeah. Check this. What's the first thing you have to do in this problem, by the way?
Okay.
Find K, the cooling rate. How quickly is this clay pot cooling? Here. Let's double screen this. Let's click over here. And of course, I'm still looking for this. So let's make sure we get this first one set up right. So to find K, if I'm solving for K, I have to replace T, D, I have to replace all of those with values. I'm solving for K. So the environment's easy enough. What's the environment?
75.
75. So this is going to be 75 plus bloop, minus 75 times E. Okay, great. What's the original?
535.
575. And what's the secondary?
535.
535. And that was when little t was how much? 10. So that's what you're solving to start. Right? That's what you're solving to start. La 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 la. Can you still see Yusef?
I think I did it wrong. What did you do?
Okay.
I just meant in total.
I didn't totally
No,
know.
because remember, K is
What do you
negative.
for the cooling rate?
Negative 0.00833812.
How about 71? So I
That's why. We just don't write it as a negative K. We have to understand it should be
because I
negative.
accidentally,
Well, it's okay.
instead of subtracting this and then dividing by this, I did all that. And
I probably did it wrong.
hate this.
What is that?
I don't even know what's in here.
Eagle.
Is it a human skull?
Huh?
Is it a skull? Like a human skull?
Close.
It's another eagle.
Okay, you did it right, I think.
Too hard.
But I got 8, 3,
Mr. Snyder.
Yep, an orange
Where's
or
the eagle?
Meagle's up here. He's taking a nap. Meagle's taking a lot of naps after they eat. What are you confused on?
How to find when you put how much longer to like wait, let it wait.
Okay.
Does that make sense? That's what I get confused about.
So let's start by solving this. So if I'm solving this, and I explained this, so people struggle with solving this, and that's I approached it from a different perspective last period. I said, I'm trying to solve for K. Here's what I'm going to do. Let e to the 10K be equivalent to the variable y. I want everyone to just stick with me. If you're struggling with this, this might help you. I'm going to rewrite this equation then. Okay, that's it. I want to solve the one on the right for y. Now, when you see that, that's an Algebra 1, 8th grade problem. What would I do next to solve this?
575.
Subtract 75.
460.
For what?
460.
460. How do I solve that?
5 by 500.
Okay. Now substitute. Y is really e to the 10K. Now do a logarithmic on it. Natural log
Of 460.
of 460 over 500
Equals
equals 10K. Divide by. All right. Now, I can do that without doing this. What I have to realize is I need to solve. I have to always start by getting this by itself. I solve for that entire thing first. Once I've done that, then I can get to logarithmic form. Would somebody give me what K approximately is? And let's take it out, I don't know, 4 or 5 decimal places at least.
I got negative 0.00834.
0.00834?
Yeah.
Love it. Okay? That's going to be good enough for what we're doing. That's going to be good enough, yes.
If we went farther out, does it matter?
No. The further out you go, the more accurate it becomes. Okay? All right, here we go. Now I do the second part of this. So the second part of this, what happens? Okay? So again, I'm starting with the exact same equation. But this time I'm not solving for K, I'm solving for T. So I substitute in, okay? Environment, we already know that is at 75. This time I'm not going to replace. Okay, now look what it says. How long before he can hand it to Mr. Snyder? So really, it's from where he's at right now. So I don't want to include this 10 minutes. Which means I don't want to go back to the original temperature. I want to go to the temperature here, because he's moving forward. This is now where he's starting his time from. So I'm going to make the original 535, and the new temperature is what I want it to be, which is 110. And I know the cooling rate, so this is going to be negative 0.00834 T. And now solving it is just like the first one, the technique we use. 110 equals 75 plus, here I'm going to get
460.
subtract 75.
45.
What's that?
35.
35. Go to logarithm on it. Natural log of equals, negative 0.00. And now what do I do?
Divide.
Divide. Divide by that. It's whatever that gives you. So it's whatever you get when you do this last step. So in how many minutes can Mr. Jordan bring down my new vase, my new pot? I'm going to do it too. Negative 0.00834. I've got, it's about 309 minutes if I round it. You guys agree with that?
Yes.
So about how much longer? About 5 hours. A little over 5 hours, right? Yeah.
I got 699.4.
For this right here?
No, for T approximately.
Right, but you plugged in.
I did it. Like
I bet it's because you don't have 75 plus. Plus. I know.
Okay, yeah, that makes sense.
Yeah, it works. Wonder if you've done that in the past and that's why you haven't gotten it right.
Yeah.
I bet. Okay. Anybody else have anything you want to say? Ask. Questions? No? Okay, so real quick, let's talk about next week before we, I just want to mention it so I don't forget. So next week, Monday, you can tell right now, we're going to have a challenge problem, and we'll go over today's homework, which is like 3 problems tonight. That's all you're going to have is 3 problems. We'll go over those on Monday, then it's a challenge problem. Tuesday, we'll be reviewing for the test. Thursday is the non-word problem part of the test. Friday is the word problem part of the test. Remember, next week, we only have 35-minute classes, so you'll have a total of 70 minutes. Thursday for the first part of the test, and 70 minutes for the second part of the test on Friday. Right? That should be plenty of time. I'm shortening the test. I'm shortening it down. Okay?
That second part, once you find the cooling rate, wouldn't it just be easier to plug that into Desmos?
Which one? You could evaluate it, you mean? Plug in T of T, put in the, like, are you saying type this into Desmos like this? And then type in T of, well, not T of T, I guess. It'd be the other way, right? Is that what you're saying?
Yeah.
Yeah, you can do that on Desmos. Okay, that's true. Desmos can be used for solving any equation. But if I want an exact answer, that's when you get in kind of a trouble point, right? Yeah.
What if on Thursday you won't be here? Like, I won't be here Thursday.
I was gonna say, I plan on being here next Thursday. What, do you think something's happening over the weekend?
No.
You're not gonna be here for sure next Thursday? What about Friday?
Friday I'll be here.
Thursday, will you be here? You're not gonna be here in the building at all.
No.
At all?
It's districts.
Districts. Districts. Well, we'll work with that. We'll talk about that on Tuesday. Let's come up with a plan. Okay. All right, so let's go ahead. I've got something I want you to try. Let's go back to a full. Okay. So I'm going to put up here, you're going to try these 2 problems I'm going to put up here. You've not done these in here, so good luck. But the first one, you better be able to do, okay? The first one you better be able to do, or we're going to have some serious problems. That's all I can say to you.
How serious will you be?
Bad serious, man. Okay, who knows?
Don't bring up the quarter.
That's my chocolate bar.
All right, here we go. Good. There you go. Like I said, we've not done either one of those in this class. Number 1, yeah, you better be able to do that one.
I haven't done that since 8th grade.
I know, I don't remember.
And 9th grade,
I remember.
probably. You did an Algebra 1, right? 2 years ago?
Yes.
Come on now. You can't forget that.
I just don't remember if I find these, man.
Because you did it the year before that as well. And you may even talk about it in geometry when you're dealing with parallel lines and they had equal slopes. Come on, don't be giving me that.
This is hard.
Oh, you're not beating you with the meter stick as hard right now if you say that.
Why is this not working? This is so
Don't
bad.
cheat me. Don't be doing this on Desmos cheating me. Use your brain.
I got the best answer.
Oh no! See what happens when you just inhale perms all day long?
Yeah, telling me that's how my teeth is.
Hazardous material, man.
That's the one thing, but why are you not working? I don't know what you want me to do, because I don't know how to do it.
Oh, you don't know what you want to do? Huh?
We're allowed to use this.
Yeah, of course you can. This is your time, not my time. The one that's in here. Look at this.
Is that an apple?
It's a ball. Gross.
It looks like a peach. It didn't look like that before. It used to be yellow. I put it in a coffee can, which had a little bit of coffee grounds in it, and it's changed color over the summer. It's a field hockey ball. It's the new weapon.
Did any of you guys learn how to do this?
No. Is it better?
Yeah, well, let me just tell you something.
Let me just tell you something. My brain remembers stuff sometimes, and then it completely forgets it and sees it.
And that bonded me.
This is so bad. How do I not remember how to do this? Oh my gosh.
2 years.
Huh?
It's been 2 years.
Oh my gosh.
been
Literally,
too
like,
long.
I don't remember how to do it. Unless I'm just putting it over the wrong thing. It's supposed to be this instead. That's 8, 9, 10, 11, 12, 13, 14, 15, 16, 20? Not 120, you ding dong. I mean, it passes through, doesn't it? I just don't remember how to find B. This is funny.
This is not funny.
To me it is, but I don't.
I have decimals.
Like investing?
No, I have decimals.
Oh god. Oh god. How do you change? Why is really bad?
So
So we had no problem. He didn't give us one.
Oh, way now. That's not nice.
Oh, why
I got like
I remember
0.6.
this, I don't remember how.
Why? MX plus E. Yes.
Well, yeah, but trying to find it.
no, it's backwards.
It's pretty easy.
So tell me what you get when you get the answer then. Oh,
You guys forget how to do slow?
Oh, Jesus Christ.
Y2
Not the
minus
time,
Y1
not the
divided by
time.
X2 minus X.
Okay, what? What?
Oh.
If I don't know how to do this, I'm getting whacked with the sword of knowledge. And not tapped, whacked.
Or with the
He might actually.
yardstick thing.
Because it's rise over run.
Oh my God.
So if it's rise over run, which is Y2 minus Y1 divided by Nice.
That's 19 divided by 3.
Bruh.
Okay, I forget what now. I don't remember what to do from there. Like,
Well, now you have to figure out where it intersects the y-axis. Which is basically you move down 19 over 3, and it will probably give you some weird number. Or you just plug it into decimals.
Oh, I smell pearl. Oh God. I don't know if it's a mouse or what, but it's fake.
Maybe it stays in your nose.
Oh. Gives me nightmares.
Oh my god.
Doing it's not hard, it's just the smell.
Maddie,
What? No, you did
I
not.
think I did.
Abby! How did you get that? That's what I did.
I don't know.
I
I'm just
literally,
guessing.
that's what I did. I don't think that's right.
I don't know. It's close enough for me.
God, bless the man.
Oh, actually,
Excuse
I don't
me.
know.
Sorry.
Oh, that's pretty easy. That's
Did you find it?
actually the intercept is the slope is 30.
Number 19.
Yeah.
Yeah, I can find the slope. I can't find B. That's my issue.
Slope's 39.
This is why I feel
Slope's
the place
39
out.
divided by 1.5. I have no clue how, but it is.
Yeah.
I'm
Just keep it in
Keep it as it was, which is 19 over 3.
no 19 over.
Look how blonde my hair was.
Yes, it does.
I plugged it in.
Oh, wow.
I'm
That's
going
really
back.
blonde. That's like,
I'm going that one
What
in
you
summer
just said
again.
is the same thing.
We were
as
in
19
Tennessee.
over 3.
No, we were in North Carolina going to Gatlinburg.
But I 19
sounds like
over
fun,
3.
though.
It was, we stayed in,
Not 39.
I forget, somewhere in North Carolina. I kind of forget Loki. But, what's it called? There's like a lot happening in the middle of bumfuck Egypt. We had no service out there. And then we went to Gatlinburg, Tennessee, which was like 2 hours away.
am I good? Am I slow?
I know, when you said all we had scheduled change, you're like, oh.
Yes,
I know,
it's
exactly.
18
That should have been me.
19 over 3. Then you plug in X with 32.
Yeah. And then
I haven't had one C this entire time. No,
I had an F.
I'm about to have a D. I had an F, and then you changed it.
I really have a 0 for second class.
What? Oh, God. What? I'm about to join you. It's okay.
A 0. My
Because all
dad
it does is
keeps my
Because all it does is quizzes. And like, I don't understand. And then we move on.
I'm about to put on the board SOS. I'm about to go to Mr. Sullivan's room.
I need to get an exponential. Huh? Exponential.
SOS.
SOS?
Yeah.
What?
I can't find B.
Huh?
I can't find B. And the equation y
What do you mean you can't find B?
I can't find it.
You can't find it for number 1?
No. I can't. I'm being completely honest with you. And I think it's because you packed us with logarithms, so now I can't remember.
Oh! Huh.
It's
Oh, so in other words, you're telling me,
It's your fault. Yeah.
if I teach you how to drive from here to Meyer, you would forget how to get from here to your home.
Yeah.
Because that's just, I'd be taking your mind off of that.
Yep.
Because you haven't learned that yet.
Yep.
Gotcha. Okay, I appreciate that. Thank you.
No, I got a fraction.
So do you take a foreign language?
Huh?
You take a foreign language?
I did.
How many words do you think you knew from that language?
A lot.
How? I mean, when you learned a new one, you didn't forget the old one?
Because I'm just cool like
You didn't
that.
like forget the old ones when you learned the new ones?
No,
Isn't that what you're supposed to do?
No, English. No.
This is a language. You guys don't view it as a language. It's a language.
Can you go look at my work, please?
Oh, I can in a second. Did you have a question, Chloe? Did you have a hand up?
Oh,
Maybe. You don't really what, right?
no,
Alright.
It's gonna be okay. It's gonna go back.
Or
All right, so now we're
Second.
finding
Very much wrong.
why don't we plug in one of the points?
No, you'll be okay. I promise.
I don't think that is.
That's what I got, and I plugged it in, and then it gave me 3/4, and that's not it. At least I let you look at my paper.
Oh my goodness!
What did I do?
Which of these is it? You've got two different things written here. Which one is it?
19/3.
Well, why do you have? I'm just curious why you had that there.
Because I thought it was x over y.
You thought rise, the vertical axis, the rise is an x.
Listen.
Oh, I am listening.
Listen here.
Yeah, what's it about? All right.
I'm asking boys today.
Oh.
It's like
Oh. All right.
Just made a mess.
So here it is. This is, of course, what I asked you to do, and you have to find those two values. M is referred to as, give me the different things you can call M, other than M. Slope,
Rise over run.
rise over run. I would never call, I would call it that, but I don't like that. I don't even like slope.
rate of change.
Rate of change. I like rate of change. Okay? Average rate of change is just as good. But rate of change is good because on the bottom one, it's called the what? Percent rate. It's a rate of a percent. So they're both rates. One's a rate of change, add or subtract something over and over again. The other one is a multiplication problem. It's a rate you multiply by over and over again. Okay? It's a rate. 1 plus or minus r. Rate. Anyways, let's go ahead and work with this. Here we go. This is easy. First, I have to find the slope. Let's find a little slide. M equals the change in y after the change of x. So when I get to the top,
19.
19, bottom,
3.
3. There it is. Leave it. Leave it. Okay, now I have to find the y-intercept. Easy enough. Here we go. What do? I choose one of the points. I'm going to choose this one. It doesn't matter which one I choose. It's my choice. And I plug them in for x and y, and I plug this in for m. So I'm going to put 27 equals what? 19/3 times 1 plus b. Oh, so 27 is equal to 19/3 plus b. So b is equal to 27 minus 19/3. Which means b is equal to, I just need a common denominator, which of course is going to be 3. So I have to rename the first fraction. And if I rename that, what do I get?
9.
Huh?
Oh, wait, no.
Huh?
Say 80.
What? I didn't say anything. I didn't say 81. What?
81.
81. 3 times 7 is 21. Carry your 2. 3 times 2, 6 plus 2 is 81. 81/3. There it is. Oh, keep going. 81 minus 19. Hey, let's see. That's 81 minus 20 plus 1. 81 minus 21, or 20 is 61 plus 1 is 62. Boom, there it is. So my equation is y equals 19/3 x plus 62/3.
Oh my goodness. You know why I got it wrong? Because I wanted to divide by 19/3.
See, you're stuck in exponential land.
Yeah.
You can't do that.
Well, I did it.
You can't do that kind of
I did
stuff.
it. I did it.
Okay? So, there's the first one. Right? That should look familiar somewhat.
Now as an exponential.
So now we're doing it as an exponential in standard form. Standard form is just what?
A plus, wait.
What does standard form on an exponential look like?
Isn't it A plus B plus C?
A squared plus B squared. C squared.
Oh, exponential.
That's it. Exponential. Yeah, I know. We're switching again. Oh my goodness.
Stop it.
This is awful.
Stop.
All right.
It's okay.
Here it is. Now,
Stop.
this one, of course, in the end, I have to have a value for A and a value for B. Okay. A stands for what?
Initial value.
Initial value. And on the graph, it would be the what?
Why?
The y-intercept. So in my other class, maybe somebody thought, oh, B is the y-intercept. If B is the y-intercept in the first one, it has to be the y-intercept in the second one because it's the same letter. Wrong. Okay, so A is the y-intercept, B is the growth or decay factor. And in there, there's a rate, the plus or minus, R. All right, so how in the world am I going to do this? Well, here's what I'm going to do. I'm going to write two equations. I'm going to write two equations, and I'm going to have to use both ordered pairs. Both ordered pairs. So, my first equation, I'm going to use my first ordered pair right here. This one. All right? So, we're going to plug those in place of x and y. So, it would be what? 8 equals a b to the -2. Correct?
Yes.
Okay. Now I'm going to go ahead and use my second ordered pair and do the same thing. Write another equation. What will that one look like? 27 equals AD to the first power. Okay. Now I like that purple one over there. That's beautiful. That's a beautiful thing. But I also like the green one. It's just as beautiful. They're both pretty. So here's what I'm going to do. I need to take this. This is now called a system of equations. When you were in algebra class, okay, I want everyone to think back to algebra class real fast. I already had you do that, but now what about this? If I asked you to solve this, and maybe the next one was, that's called a system of equations. What was one method of solving that? Yeah. Substitution. And what you did, hey, since y is 6x minus 2, I could go up to this equation and plug 6x minus 2 in place of y, and then this first equation would be in terms of what? X. I'd solve for x, get an answer, plug it in here, I'd get back y. You did that. Okay? We're going to use that same concept on this problem I'm asking you to do. Here we go. What I need to do is I need to take one of my two equations. It doesn't matter really, but I'm going to just choose one of them, and I'm going to solve it for A. All right? I'm going to take this one and solve it for A. If I solve this for A, how would I solve this for A? What would it be if I solved this for A? How would I get A by itself? Divide by what? Divide both sides by what? B to the -2. Wait, right? Is that right?
Mm-hmm.
Just stick with me for a second. Now I need to know, what does that end up being? What is 8 over b to the -2? What happens to that b to the -2?
I thought it turned into 1 over b squared, but I don't remember.
Not 1 over b squared.
Couldn't it be 8 times b to the positive?
Yes. Remember, this goes to the top and becomes a positive exponent. So this is really 8b squared is equal to a. Okay? That's negative exponents. Now what do? I take this to the other equation and substitute it in place of a. So I get 27 equals 8b squared times b. Which means I have 27 equals 8b to the third power. Now how do I solve that? Divide by 8. So I get b to the third power equals 27 over 8. Now I can do this multiple ways, but I want a number here.
1/3.
Okay, not multiply. Raise to the 1/3 power. That's the same as what root? Cube root. I'm going to write it as the cube root because guess what these are on the right? Those are perfect cubes. What's the cube root of 27? 3. What's the cube root of 8?
2.
I now have b. How do I get a? I plug b right in there now. So A is equal to 8 times 3/2 squared. So I just went, boop, plugged it in here. That gives me this. A equals 8 times, what do I get here? 9/4. 4 goes into itself once, goes into 8 twice. So I get 18. Now I have A, I have B, I can write my equation.
Why did you just do the bottom?
Huh? How did I do this?
Oh, you did the butterfly method? I'm confused.
No, I reduced before I multiplied. I don't know of any butterflies in my math class.
I'm not gonna ask.
Yeah, don't. I don't use the butterfly method, whatever that's called. Yeah.
What if 27 and 8 weren't cube roots? Would you just plug that entire thing over into A?
You'd have to then, yes. But I chose one that it wasn't like that. So my equation then is what? Y equals A, 18 times B, 3/2 raised to the x. Boom. There it is. There it is. Did it. Done it. I'm good. We're cool. Right?
You make it look so easy.
Yeah.
and
If
it's-
if I'm not doing it easily, then that's bad.
Well,
I mean, I shouldn't be struggling up here to do it myself. That'd be like a teacher in your foreign language not being able to take something from a French 1 book and translate it into English easily. That'd be a problem if they were teaching French. Right? That'd be a big problem. You know? Or that an English teacher didn't know that you capitalize the first initial in a proper name. That'd be a big problem. Right? Yeah, this is a problem if I wouldn't be able to do this. Now, do you guys have anything you want to ask? And I'm more interested on the bottom. I mean, this here was just to let you know you did the same kind of a thing for linear way back here. Now we're approaching this and doing it for exponentials all. Yeah,
So,
either one. Doesn't matter.
go. Oh my gosh. Okay, so when we had the 8 equals AB to the negative second power or whatever, how did that just go from 8B to the second power? Like that.
How did this go to this?
Yeah,
Because we divided by b to the negative 2.
yeah.
And right here, this guy, 8 over b to the negative 2 is equal to 8 times 1 over b to the negative 2. And that is b squared.
Oh.
That's why.
Okay.
Because the laws of exponents says what? X to the negative 1 equals 1 over x. 1 over x to the negative 1 is x.
Oh.
That's the inverse property. That's that one that just, all it is invert it and make it a positive exponent. That's why 1 over b to the negative 2 becomes b to the positive 2. You invert it and make it positive. Right? Yeah.
so in tonight's homework, is it going to be set up to where if you have to take a cube root or square root, it'll work out, or do we have to like?
I don't think I have anything that's gross tonight. I think everything for the most part is pretty nice. Yeah. Okay. We're ready to try your own? Try one? Give me your best effort. I think I have, there it is. Booyah. Got one ready for you already. Try that one out right there. Okay.
Hey, guys.
Before we
No. No linears. I just want you to do exponential.
Oh, okay.
I only made you do linear as a
Refresher.
it's a refresher of you found equations before, given 2 points. You can do it for linear. You can do it for exponential. All right? A lot of things you can do it for, as a matter of fact. Because given 2 points, you don't know for sure if it's a line or if it's exponential or what it is. Could be square root property. Who knows?
I just forgot it.
What's that?
Everything.
That I just did?
Yep.
You got this problem written down?
Mm-hmm.
Here. Oh, let's go back.
Wait, hold on.
There you go.
something as 2 over something squared? Like 2 over d squared equals a? That doesn't sound right.
You could, yeah, that's fine. The reason mine didn't look like that because I didn't want negative exponents. I always take my negative exponents and rewrite them as positive exponents.
But this one's not negative.
Right, so leave it as a positive exponent.
Oh, okay.
It'll be beautiful, trust me. I know it. I did this problem earlier and I got it right
Well, of course you did.
on the second attempt. It took me 2 tries.
What was the second set of points?
What was the second? What was it? Oh, I thought you read it. Didn't I just ask, did you write this down?
The other one. Thank you. I'm just gonna write it on. Okay. Carry yourself up.
This, Shabao. Georgia, Savannah, you gonna give me one of the equations that I should write down up here to do this problem? Can you give me one of the 2?
2 equals.
Love it. Yep. I wonder who's gonna give me the second one. Probably the loudest kid in class. Timothy.
3 equals AB to first. Or wait, no.
It's fine.
I have it written backwards on mine.
Okay, well, what should it be? Just tell me.
Is equal to AB to the third.
1 equals AB. All right. So that's our starting point. Now I need to go ahead and solve for what? What letter did I solve for? A. And why do I do that? Because A is to what power always? The first power. That's why it's the easiest one to solve for. Okay, I don't want to start by solving for B here and then plugging in over there. That just gives me grossness. Because if I solve for B here, I'm going to have a square root of 2 over A. No, thank you. I don't want that.
That's what I did.
That's what I did.
Yeah.
That's
And I didn't say anything before because I just was curious. Look, and here's what I'm saying. If I do this and I say, oh, I'm going to solve for B, it would be B squared equals 2 over A. So B is equal to the square root of 2 over A. And then that gets plugged over here and I get this. I just really don't like that as much. I don't. Could I deal with it? Yes. I sure could because I would just do this. And this I know is what? 2 over A to the 3/2 power.
I solved for A on the left side.
You just said you solved for B.
No, I solved for A.
What did you just say you solved for B?
That's what I thought I did, but I still have something confusing.
Say what you don't mean. Wait. Yeah. Huh?
Did you say? I thought you were. I thought.
So
you were
if you
actually
do,
saying
look,
this.
so guys, if you do this to substitute, if you solve for B to substitute over there, you get grossness. You don't want to do that, okay? So we're going to, I'm just going
You
to,
were actually doing it. I didn't.
I was doing it, and I could continue doing it and get the right answer, but I'm not going to because it's just more confusing that way. All right, so here's my next question. Does it matter which one of these I solve for A?
No.
It really doesn't matter. I will tell you right now, I always take the one that has a smaller exponent for B, which means I'm going to solve the red one. Now, I'll show you why in a second. So this gives me that A is 2 over B squared. All right? Then, of course, what happens? This goes there. So I get 1 equals 2 over B squared times B to the 3rd over 1. Which gives me what? 1 equals, what's going to happen right here? How many B's am I be left with, and where are they? It's this, guys. What does this give me? B to the 3rd over B squared.
2B.
Just plain old B. What do you do with the exponents? Subtract them. 3 minus 2 is 1. So it's B to the 3 minus 2 or B to the first power. So what do I get? 2B. Oh my goodness. Look what B equals. 1/2. Guess where that goes? Right there. Now I substitute in this equation. A equals 2 over 1/2 squared. A equals 2 over 1/4. What's that give me? Who knows? 8. Now I've got A, I've got B, write my equation. Y equals 8 times 1/2 to the x. Right? Okay, so what I just said was I always choose the smaller one for a reason. And here's why. I can do this one over here and make it A equals 1 over B cubed. I'm allowed to do that. I could do it this way, guys. It'll give me the same answer. And that goes there, so I would get 2 equals 1 over B cubed. Yeah, times B squared. This gives me 2 equals B squared over B to the 3rd, which means 2 equals 1 over B to the negative 1. I know how you guys hate negative exponents. So guess what? I avoid them. How do I avoid them? By always doing it the way I said. Getting the smaller exponent on the bottom always. B to the 3rd over B squared. You're always going to have the positive exponent if you do it this way. Here you'll end up with a negative. If you're good with negatives, it doesn't matter. All I have to do here is flip both sides. 1 over 2 equals b. But again, negative exponents are not your strength. So we avoid things that are not our strength right now. So I say, go this way. If you go the other way, go for it. I don't have a problem. You can get there. You can solve for b and do it and make it work out. Okay. If you can't, I'll help you if you want to try it that way sometime. All right. I'm tired. I'm tired.
Me too.
Man, I think it's because I've been working harder than you today.
I believe that's a lie.
Oh, I don't think so. I've been a lot more active in here than a lot of you. Okay. But I love you guys anyways. Don't let anybody else know this. You're my favorite class. Yeah, it's good. You're my favorite class. You really are.
Is that why the meat was napping?
He has nobody eating here. He doesn't need to. All right. So, here we go. Oh, I'm not going to make you do that because you would just be mad at me if I made you do this one, right?
I would cry.
Yeah, you would cry. All right, here we go. So, guys, here we go. These are the 3 I want you to do for homework tonight. This is it. 3.
Okay. Write them down.
Boom, boom, boom.
0.31.
Oh, cry! Jeez.
I like that. Hey, at least it's better than a fraction.
I'm going to see it. Someday you're going to have a boss, and your paycheck every month is going to be like $8,000.49, and he's just going to give you $8,000 instead. Say, you don't want that 0.49 anyways. Not a big deal. Over your lifetime, it won't matter.
I'm gonna do this week.
That's literally what they do at my job.
You guys are. I don't know where you guys learn to hate fractions, and I do know where it is. Lower grades, they avoid them.
This is older. I'm just kidding.
They avoid them. You guys complain down when you're little, so they stop giving you those because they don't want to hear you complain. So then when I give them to you, you complain, and I go, I don't care.
Yeah, no, that's not.
I'm immune to your complaints. I don't teach little kids.
Hey, here's the thing. That's not how it worked for me. They gave me fractions.
Yeah, well, not everyone gets that,
Because I was
that
too
luxury
smart.
when they're little. That's a luxury when you're little. If some teacher cares enough to give you decimals and fractions on a regular basis to let you know that in real life, whole numbers don't rarely exist. How many times have you gone and bought something and actually paid exactly $28? Almost never.
1 out of 100.
Almost never. You're always going to be like $28.32.
I feel a lot of people's like.
Well, but even better.
I like how
Twice
he's
in my
so
life,
specific
I've paid
on that
exactly
32
on the
cents.
dot.
See, I round up when I go to restaurants, so like when I tip them, I round up with the change. If it's like,
That's nice of you.
well, it just makes it easier on my card. I don't like all the,
But then you have to add decimals. Why would you want to do that?
because I like even numbers.
But if your bill was $32.56, then you have to know exactly what to add to that to get to another dollar to round it up, which is what?
44 cents.
See? So you understand how to work with decimals. So that's why you're not afraid to do that.
But there's no A, B in front of it.
No, but I'm just saying you're not afraid to do that. You're not afraid to do that. That's what I'm saying. That's good.
Yeah. That's,
Some people wouldn't do that.
oh, no, I do.
Some people do that because it's easier to balance.
Mm-hmm.
I'm just saying. Some people avoid fractions and decimals at all costs.
My card does that automatically. It's
You're-
set up so that it like the decimal goes into an extra little thing.
Yeah, right, Pat?
Yeah.
That's what mine does too.
You can do that where it rounds it always. Does it always just round it up to the nearest dollar?
Yes.
If you're odd even dollars, they kick an extra dollar in or not? Like if it's $32, does it make it 33 instead and kick it into that thing? Because my son has one like that. Or if
Oh,
it's that he can set it for if it's a dollar on the actual amount, it'll kick an extra dollar into the account instead for rounding up. Which that's fine if he wants to do that. It's saving money. So
I wish they would have locked my savings accounts.
what's that?
I wish they would have locked my saving account.
They didn't lock it,
Nope.
and you've been using it. So it's not been a saving account. It's been a spending account. You're saying? Yeah. Oh!
You want me to tell you how much is in it right now?
Uh-oh.
I'll tell the whole
Please tell me
world.
it's not negative.
Oh, I hope not. I don't
Well,
think it is.
Me too.
Oh my god.
It's negative.
No, I'm $1.63.
You're approaching.
It's very close.
Whoa!
And then there's $9 in the other one and $9 in my checking
Hey
account.
man, you're loaded for the weekend.
I get okay. I have a pay card though, like
You
an
have a what?
ADP pay card. That
I have no
displays
clue what
it.
that even is.
So instead of going to my debit card, they gave me a pay card, which is the stupidest thing ever. Hold on.
I don't have
A
it.
pay, that's different
Pay
than,
card.
it's not a debit card. It's like a charge card, but it comes out of your account.
No.
It's like a charge card, but it's like a charge card,
What's the charge card?
like a Visa. You say it's like that, you
Kind
charge
of,
it.
yeah. It's kind of like a Visa card, but it's weird because it's not linked to my personal banking account. It's to one through my work through 5th, 3rd. So if I want, like, I try to get direct deposit into my actual account because everything, like, I have memberships and stuff I come out of that one. But if I want to transfer money, it takes like 2 days.
Gotcha.
I gotta do that right now. But I'm trying to see if they'll have a direct deposit thing because I don't like having 2 cards.
I don't either.
Aggravating.
Aggravating.
Yes.
But hey, Yusef, I'm signing off now. You take care. Have a good weekend. Have these 3 problems done. You're going to give us the answers on Monday.
Okay.
It's not me.
You okay with that?
Yeah, it's fine.
Hey, Yusef, I'm signing. That's delayed. I hate that. All right, but
it was
peace out, Yusef.
My headphones died. I'm
Oh
sad.
no, and you'll have $1 something to charge them.
I know, right? So I have 170 on my other card.
Oh,